In this video, we're going to look at few other databases which are not very common, but it's a trend that is picking up right now. So we're going to first look at object relational databases. So in object relational databases, we make use of our object-oriented concepts. So over here, our elements are represented in terms of objects and variables. So variables are similar to your attributes, and objects are your tuples, if you were to like take an analogy with your relational databases. So over here, objects have a capacity or capability to send messages to each other, and then these messages are sent via methods. And obviously, since it's an object-oriented, it's based on object-oriented concepts. An object is an instance of a class, so you can still use your object-oriented concepts like inheritance here. So this is how an object-oriented model looks like. So you can basically have one object which stores, let's say, date, activity code, root number, so on and so forth, and then you can inherit another object from it. Like let's say if you want to like elaborate on activity code, and then you can treat it as another object and then go ahead and then expand it. And the next one we have here are temporal databases, sequence databases, and time series databases. Temporal databases are they are again relational databases, but this time around data is stored in terms of time related attributes. Sequence databases are databases which store information in some sort of order, but they do not have any concrete notion of time. That is, you will not know whether it has occurred at 9 p.m. or 10 p.m. or so on and so forth, but you know that it has some sort of order. And then you have time series databases where you extract information periodically, that is, let's say every 1 year or every 2 years and so on and so forth. So where do we use data mining here? I'll give you a small example. So this is how our time series database looks like. It's not exactly a time series database, it's a temporal database rather, sorry. So what is happening here, this is recording the events that have happened in the life of a person named John. So these are all the events. So this attribute here, it shows all the events that have happened in the life of John, and this is what the database is showing. So it's sort of like recording these events. So initially there was no John, and then there was nothing special happening in John's life except that he was living in a town called Smallville, and then he moved on to another town called as Big Town, and then finally when he passed away there is no person called as John. So that's what the database is recording. So similar things can happen with let's say weather forecasting system. So you can like identify or store the different temperatures or the different precipitation levels that have that were associated with, let's say, the previous tsunamis, and then if the pressure levels and the precipitation levels are approaching those previous levels when the tsunami has occurred, this time around we can identify the tsunami beforehand and then alert everyone else. And then we have spatial databases and spatial temporal databases. So spatial databases, they contain information such as maps, satellite images, CAD images, so on and so forth. And spatial data can be stored in terms of raster format or recta format. I'll not go into much detail because our syllabus does not cover this. So you are free to explore this. I will post a small quiz question on it just to make sure that you guys have explored it. Okay. So what kind of data mining can we do here? All sorts, right? So if you look at satellite images, let's say you're working with an agricultural company and then you want to find out whether sowing some sort of seeds in one particular season will help benefit the farmers better. So you can like look at satellite images of soil from different regions in the world and then see if you have similar soil types in your country, and then find out if you can implement the same here. So that is one application for your satellite images data. Spatiotemporal databases is one that stores information with time. So all your spatial data with time is what you have in your spatiotemporal databases. The same thing can be done here. So weather forecasting system is a good application to it. So this is how you store information in spatiotemporal databases or spatial databases. So if you look at this, we're trying to store heat waves in a place called Cologne. So each of these different colors indicate different heat zones. So that pretty much helps us realize which places are hotter or which places are colder in a given period of time. Next, we have text databases and multimedia databases. By text databases, I do not mean our original relational databases. These text bases, they store a lot of text, maybe in terms of paragraphs or essays. So they store a lot of text. And these can be unstructured or semi-structured. So unstructured as in they need not have any structure. Like if you go on internet, people write all sorts of information, right? So they do not have any structure to it. Or they can be semi-structured. So you can have some sort of tables, and then again that could be followed up with some sort of regular sentences. So it could be like mix and match type. And multimedia databases is where you store all your audio files, images files, and video files. So how can you use data mining here? Obviously, with multimedia databases, you can use it for image classification. Like let's say I give you 100 pictures of different animals, and then I give you another picture, and then I ask you to predict which animal is this picture. And then if you perform data mining on top of all your 100 images properly, you'll be able to predict it. Similarly, you can use your text databases to summarize them to help instead of like trying to understand what is being said by looking at the entire document. You can just use an algorithm to help you summarize it or find out what topic the database is or the document is talking about. And the biggest problem with them is storage, since this is a lot of information. Same is the case with spatial databases. The biggest problem here is we need to store a lot of that information, and this is also called as continuous media. The reason being, the data keeps coming in all the time, so our database grows at a very fast rate. So obviously we need to be pretty much alert, and then our data mining systems have to be scalable to that enormous amount of data inflow. And so this is how a multimedia database looks like. So we're here, instead of just having numbers and text and varchars, you'll be having different kind of data types. Like you have something called clob, you have something called b file, a blob. You can still have varchars, so that's nice. You can still have numbers, but yeah, you have some extra ones like map type and so on and so forth. And then heterogeneous databases and legacy database systems. So heterogeneous database systems are those systems which are interconnected, but each of them, they act like an autonomous database. Like each of them have their own capability to perform all the different operations, but these are connected together. The problem here is the integration of all of them. Since every database is independent, so each of them has their own structure. So when you try combining them together, obviously that would be a problem. So when you like connect a lot of these heterogeneous databases, that brings us with another database called as legacy database. So this is what we have seen in data warehouse to an extent. So obviously this is something like an overlap to it. And then we have data streams. So if you look at YouTube, we have a lot of information coming in, going out. There are some audio podcast channels as well, some radios on your internet as well. So all of these, they can come under your data streams. So yeah, data comes in and then goes out continuously here. So once again, you are dealing with a huge amount of information. So storage will be a big problem. Other examples would be video surveillance and network traffic. So you need to build up a new query model here. And this query model should be continuous in nature, or else it will be very hard to study all of this information that is coming in and then going out. And how is data mining helpful here? Let's say we look at video surveillance. It can help you catch a thief who has got down into your house. So that's one good example that I could give you here. And then this is how the entire structure for data streams looks like. So let's say you have data coming in from different sources. So there could be a CSV file, there could be a Google spreadsheet, so on and so forth, some sort of URL, and then you send all that information to a data stream processing center, and from there on you can categorize that and then send it to different databases like a relational database, or you can create an OLAP report, like etc. Right? And finally, we'll wind up with something called as World Wide Web, towards which most of the databases are moving on to right now. So how is this different from our other databases? Over here, data is interconnected by links. So how do these links work? Pretty much this data is always unstructured. So that is something that is a given thing. But the links are associated with tags. So when you, let's say, search for Apple, it sorts out all the records based on some sort of an algorithm, and based on that algorithm you'll be getting search results related to, let's say, Apple the fruit or Apple the mobile phone. So that way your data mining can help you categorize things in World Wide Web. This is just like a very high level introduction to all the data repositories that you have. If you're free to explore most of these. We are not going to go into much detail on these in this course. So that's all we have in this video. In the next video, we're going to look at the different patterns that can be mined in data mining. Thank you.